Welcome to the final review video on exponential equations. Exponential equations, remember, are any equation where the variable x is part of the exponent. It could be the whole exponent or it could be just one of a number of terms. It's a great thing to start out by identifying the type because exponential equations have a really signature first step. And the first step is if we're ever going to get x by itself, we're going to need to somehow rearrange this expression so that the exponent is no longer an exponent. This should start to ring some bells for you. If we start at an exponential equation, we're going to change this whole thing around to write it in a format using a logarithm. We're not technically just making up a logarithm. We're not evaluating a logarithm. We're just rearranging the pieces in a different way. When we do that, the base goes to the bottom of the log. The answer of the exponential becomes the argument, and this exponent will turn up on the other side of the equation like a normal expression. It'll no longer be stuck in exponent form, looking like this. The benefit to this is an equal sign here in the middle, is that now it's pretty easy to get x by itself because this stuff is just a number. And that's the whole point of the log. You shouldn't try and memorize that you are supposed to use a log. You should understand why we do that. The goal is to get x out of the exponent so that we can isolate it because ultimately we want to get x by itself. Pause the video here to work out the example for yourself. Maybe record some vocabulary if you need to. Here's the first answer. If you're struggling with the logarithm, think about the meaning of this logarithm. Is 3 to what power equals 1 over 27? And that should explain where this negative 3 came from. The next example is pretty similar. The only difference is we have an extra coefficient out front. Before we can do that step where we rearrange everything, you need to have the base and the exponent isolated. So we divide by 200, and then we move to our logarithm. I'm going to go ahead and work out the next example before I go over to the two for you. The next example at face value seems pretty straightforward, just like the last. We're going to isolate the base and the exponent, and then we're going to change it to log form. Isolating means subtracting 3. And then we have sort of an interesting situation where we can kind of forecast that if 5 to the x power equals 7, x can't be a normal integer number because 5 can't turn into 7 by multiplying by itself. So at this point, it would be a great idea in your video to estimate what you expect the answer for x to be. I expect the answer to be between 1 and 2 because 5 to the first power is 5 and 5 squared is 25. 5 is less than 7 and 25 is greater than 7, so my actual exponent should be somewhere in between. To get the actual exponent, you'll use log form and then the change of base formula where the argument goes on the top and the base is on the bottom. These numbers came from the calculator and I divided them for my final answer. Pause the video here to work out the next two example problems for you. When you press play, I'll show you the answers. There's the first one, and here's the second one. The last example is actually kind of a different strategy here. In fact, this is a shortcut, and it's a shortcut that we can use because we happen to have two bases. Again, exponential equation because the exponent has a variable, but our bases are related numbers. If the bases were the same, I could cancel them right out and solve it like a linear algebra problem, and I would consider myself lucky for such an easy final. In this case, you have one quick step that you have to take, and the key thing is to remember which base you have to rewrite. Always rewrite the larger base or the more strange base. So for example, if you had 4 and like 1 over 16, we would rewrite that one because I can easily write it as a power of 4. Don't just change the 4 into a 16. You're not allowed to actually change the numbers. You can just rewrite them. So by writing 4 squared, I haven't changed the number. I've just shown it in a different way. Now that I have 4 squared, the product rule says multiply your exponents. And if I have the same base, the two exponents on either side must equal each other. And so from there, it's just a linear algebra problem. Take a moment to look at this work and then work out your own on the side. One last one with everybody's favorite number, which is e. So this is fundamentally still an exponential equation. If you would like to use the correct vocabulary in your video, you should say that e is Euler's constant. Think of the team. Euler's constant. Euler's constant, E, is a number. You absolutely must say something to that effect in your video. It's just some number, but it's irrational, so it's easier to write E than to actually write what the decimal is because they keep on going. If your variable is an exponent, we will use a logarithm to rearrange this. First, we're going to isolate, so we subtract 1, and then we divide by 2, and we get e to the x equals 3. Now, normally to get the x by itself, we would switch this to a logarithm, and the base would be e, and the 3 would be inside. And of course, it would equal the x. And the good news is x is now by itself. The harder news is that this is kind of weird. We're not really used to log base e. How many times do you have to multiply e to get 3? That's not something we can really conceptualize. So this is a special function that's used all the time in real life because of e's relationship to a lot of common phenomena. And it's so common that we give it its own name. And log base e is just a fancy way for writing what we call a natural logarithm. So log base e and ln, those are the same thing. It's two different ways of writing the exact same math. So ln of 3, that's just something in your calculator where you can go and you can find this ln button, put 3 in first, and then press the ln button, and you turn out to have an answer of 1.098, which is what your ultimate answer for x is going to be. Okay. Pause the video here and work out the one for you. Here you go.